All right, so here's a slide you probably haven't seen this entire conference, just letting you know there's possibly some forward-looking information here that we may get into. So here's our agenda. So we're going to talk about Composer, just a general overview, limitations. We're going to go into architecture, kind of a deep dive on anatomy, just all the pieces and parts that make up a linked clone or a composed desktop. We're going to talk about some operational aspects of things, application management, patch and update management, antivirus, business continuity, and disaster recovery. And if it's anything like the last time we did that session, the last couple slides, we're going to move through really quick. So just a couple of things at the beginning. Why would you use Composer? A big reason is just storage savings. One of the things that blocked people from doing virtual desktop for a long time was I have to use a ton of disk space to do it out on my relatively expensive SAN. This will save you conservatively 50%, more like operationally probably 70, 75%, maybe even more in terms of disk space. And we'll get into that in detail. Allow you to make changes on multiple desktops, entire pools of desktop with one real operation to do that. Get desktops deployed very rapidly. We use a thing called Quick Prep, which we'll talk about. Also, a lot quicker to copy out a linked clone than it is a full clone of a disk. And you're also, if you have the Premier bundle, you get it. So why not use it? A couple of things in the limitation area, just to get that out of the way. An 8 ESX host cluster limit if you're using linked clones. The normal limit is 32 hosts in a cluster, but we bring that significantly down just because of the number of potential read-write operations that are happening at the same time. So we're going to limit you to 8 nodes in a composed disk cluster. The number of desktops on a host, we should have put that on the slide but didn't, but specifically on a host, may be limited by some other factors. For example, HA restarts. Well, with vSphere 4.1, a lot of that's gone away because we can actually restart 320 VMs in a failure. Also, the time required to bring that back up. So if you lose a host and you got 200 desktops running on there, it's going to take a little while for us to spin all those back up. So you're going to have some downtime there. Also related to that, vMotion for maintenance mode. If I've got to evacuate 200 machines and I need to get a host in maintenance mode, you've got to plan that into time. Antivirus updates can also impact the performance of a host, but we'll get into some technology we've got coming that Steve announced on Monday, the VShield Endpoint. We're going to talk about that because it does help a lot with the antivirus story.
Are these numbers all 4.5 View?
Those numbers specifically are vSphere 4.1. So those are vSphere related numbers.
And also, I think it's 4.0 update 2 as well.
Yes,
right?
Yeah,
so,
right.
So these are those numbers on the number of VMs per ESX host. It's around vSphere, not View.
Anybody else with a question? Great.
64-bit per share?
That, yes. Yeah.
On the 4.1 it is,
yeah.
because 4.1 is only 64-bit, right? But with vSphere 4, that is not necessarily 64-bit, right? Because we do allow a 32-bit vCenter server with vSphere 4.
Okay, so just a couple of quick pieces and parts. Composer itself runs on the vCenter server as a service. It uses a database. Those of you using this already know this. You just usually set up on the same database server that you're setting up the vCenter server on. The View Manager server then connects to Composer. Now, the way we do this is this dialog here. So you got to specify a couple of things, the vCenter server you're attaching to, and just a couple other things I'll call out. You're going to tick the box to say, I want to use Composer. We've changed the port with 4.5 from 8443 to 18443. And then the other thing I'll mention here, because it's important, when you add the domain, you're going to get a dialog box that has a domain and then a different field for the username. You want to put in that field the fully qualified username, so domain and username, rather than this where I just got the username in that field. This will make sure that we can log in and the credentials will get accepted properly. So just a few things in terms of terminology and anatomy of a linked clone. So we talk about a parent VM, which we also call a gold image, a base image, a master image, and we may use those names interchangeably here. Sorry about that. It's just force of habit. A snapshot, storage, replica, and linked clone. So the parent VM is just what it sounds like. It's my fully tweaked. It's got my OS that I want, whether it's XP or Windows 7. I've got all the apps that I want installed, that patched to the level I want, and that's what I'm going to base my linked clone desktops off of. So just a few things on best practices there. I'm not going to call out each one of these. The biggest things are to look for the deployment guides. So we have an XP deployment guide, and now there's a Win 7 optimization guide that'll go into detail about, what services you can shut off, what, how to really configure that base image for a virtual desktop. And so there's a lot of great detail in the Win 7 optimization guide. Another, as I said, I won't go through all of these, but another one is just in general, don't P2V a physical desktop it's much better practice to build a desktop up from a base, as a base image. You just won't bring along any legacy junk that you've got sitting out there. So now I've got my parent VM, and I'm going to make a snapshot of it. Really important here that it's a powered off snapshot. We don't want to capture any memory states. We want to have that VM powered off when we make the snapshot. And I can have a catalog of snapshots for that machine. Now you want to follow typically best practices around snapshotting and not have 40 snapshots, and some of them are a year old. Not a great idea. But this is where I would then go in, excuse me, and select which snapshot I'm going to use for my linked clone, because when my base image for my linked clone is actually a combination of that parent VM and the snapshot. So you have to have a snapshot in place to make that, to make the linked clone. Any questions at this point? Okay, good. Like we said, this is maybe a little bit of review for some of you. Just in terms of storage, Jeff, I'm going to let you jump in here.
Go from here?
Yeah.
Okay. So most people, when they deploy link clones, they still deploy them on ESX clusters that have HA and DRS provisioned, right? But we do have the ability for you to actually choose data stores that are local disk for the link clones to reside on. From a cost perspective, it's less expensive storage, right? We're going to get into this in a lot more detail in a couple slides. But we're gonna walk through what that data store browser. We're gonna show screenshots of the data store browser, so you can see where each of these files resides and what the function is. Link clones with vSphere 4.5 and Composer are dramatically different than link clones with View 4. Right? View 4 is very different. So one big difference here is that now with View 4.5, we can actually separate out that replica and put it on a different data store than the link clones themselves. So with View 4, the way we would do this, right, is we're limited by I/O, right? So just in general, if I'm going to do, just to make up numbers here, I'm just completely making this up as I go along. If we're going to do, let's say, a pool of 500 desktops, and let's say I know how much disk I/O I'm driving per desktop, and I determine that each of my data stores can handle 50 link clones, just to make my math easy, right? Let's say I know I'm going to do 50 link clones per data store. I would need 10 data stores, right? So with View 4, what we would do is View would automatically create a replica in each of those data stores, in each of the 10 data stores, and that replica is a combination of our parent image plus that snapshot that we took. So it's generating a completely new full VM that we're calling a replica and placing it in each data store. And then we're building the link clones in the data store and tying them to that replica. We don't want to tie the link clones to that parent image because we still want to be able to power on that parent image and manipulate it to update applications or Patch Tuesday or things like that. So this replica is a very important concept to us, right? So historically, we'd place a replica in each data store that we were going to place link clones in. Now with View 4.5, we can break that replica out and put it on a different data store. We can put it on a completely separate data store. Now, why would we want to do that? The big thing that's driving this is now with the advent of solid-state disk enterprise flash, right, that can really drive I/O operations. We're going to give you the ability to buy a small amount of solid-state disk, place that replica on that data store for the SSD, and then create my pools of link clones on less expensive storage, but get all the I/O benefit of that SSD drive. Does that make sense? Yeah.
So the replica would be handling mostly read I/O, correct? Most write I/O is
correct. So the comment in the front is that replica will handle all the read I/O, and most of the write I/O is all going to go to that link clone that's on that less expensive disk. That's very accurate. We still need to make sure that we understand that I/O footprint of the desktop so that we can put enough spindles underneath to deliver the I/O that's required for that desktop workload, right? At the end of the day, the one thing I want to really stress here is the importance of architecting that back-end storage to be able to handle the I/O requirements. And the most difficult thing is understanding what that I/O requirement is, right? So when I go out and talk to my customers about this, I ask them, okay, so do you know, like, how much I/O do you produce per desktop? Nobody knows that number, right? Does anybody in here that know that number for their environment? This guy.
Else, yeah.
Stand up and be recognized. Okay, so I'm going to ask a question. What kind of tool did you use to discover that information?
So there you go. Yeah.
Give that guy a hand. The reason I'm applauding him is because going forward, what we'd like to see everybody do is to do an assessment of their physical desktop environment so that they can truly understand what that physical desktop looks like and how it behaves so that we can correctly architect that back end that when we're designing this view environment, right? It's very, very critical. So there's two tools that do it. It's Lakeside and Liquidware Labs. We're not affiliated with either of those companies, but we do recommend that you go through and do that assessment piece. I think that's important. And I don't mean to go too far down into the ditch on this topic, right? But this is important stuff, guys, right? Question? No. The question is, do we still create one replica for each data store? No, we don't. We only can create one replica per pool using 4.5 if we choose to separate out that replica. Now, let me make another point. If all of my data stores are the same and I'm not using SSD, then we would say you wouldn't separate this out, right? I wouldn't put my replica on one 15K fiber channel data store and all my link clones on other ones. I would architect it the way I do with View 4, right? I would just, again, round robin over however many data stores are required and place a replica in each. The architecture with View 4 is fine if I'm not using very high performant disk like solid state disk.
One other thing I'll throw into the mix here is if you're using the tiered storage for the replica and choosing a data store for the replica, we'll at this point only let you choose one data store for that. So you need to have some sort of high availability architected into your storage if you're going to use that SSD option so that there's a failover path. So if you lose that data store, we can fail over to another one. The desktops can handle a short outage of having that replica not available, but you'd want to have something in there just to not have that single point of failure.
There was another question. Anybody? Yeah. Sure. The name of the companies that provide the assessment tools, it's Lakeside Software, and the other one is Liquidware Labs. And they're both here on the show floor. You can find both of them. And they have partners in all of your geographies, and they'll be more than happy to come out and help you with that desktop assessment. And they produce a report that tells you about the applications that are running in your environment, how often each application is used, whether the application is a good candidate to be thin-apped, a ton of data. I know that's off topic, but I highly recommend that you take a look at those tools. So now on this screenshot, we just want to point out that even though these are both NFS data stores, that we can actually say I want my replica to be on this data store, but I want all my link clones to be on a separate data store, right? I can configure that. Is this logical, guys? Okay. The other thing I want to point out here is I can choose to use, this part, a different OS disk and View Composer persistent disk in different data stores. Now, anybody in here familiar with user data disks? That's a term that we used to use with View 4, right? The user data disk where we kept the profile, or we could keep the profile. So marketing in their infinite wisdom has decided to change the name, and now it's going to be called a persistent disk. Persistent disk is actually a more accurate term. It's just unfortunate that they didn't start with it. So the new term is persistent disk, okay? But the idea here is that if I can take that profile in the persistent disk and put it in a different data store, now if I want to plan for a DR contingency, I can actually put those persistent disks on a LUN that's being replicated to that other data center. I generally don't care about all of my link clones because they're disposable anyway. But those persistent disks that contain my users' profiles, I might want to replicate those and protect those. Is that logical? Questions? Okay, let's go on here. The other thing I want to point out here is the conservative and moderate. So we're talking here specifically about overcommitment of disk. So what do we mean by conservative and moderate? So what we're really talking about here is how large do we think those link clones are going to grow, right? So link clones generally start out very, very small. When we first create that link clone, we're looking at 100 meg or something in that area, right? But over time, that link clone grows as users make changes and do things. The size of the link clone grows. So we're going to set that conservative to aggressive amount of overcommit based on how large we think they're going to grow. So I'll give you an example of what we're looking at here. So if I'm a hospital and I have a nursing pool, right, where every time a nurse logs in, he gets a virtual desktop that's a floating virtual desktop that as soon as he logs off, it destroys it, right? So it doesn't exist for very long. So it doesn't have a chance for the link clone to grow very large. If we're destroying it every time it's been used and it doesn't get very large, we can be very aggressive with the amount of overcommit because we know it's not going to get very big, right? Now, conversely, if I know that it's doctors and that I'm only going to refresh their desktops once a month, when I do Patch Tuesday, over the period of a month, their link clone could grow very large. So then I want to be much more conservative on how much storage I over allocate for the growth of my link clones. Yeah?
Is there a way to cap that? Say that the link clone will only grow to, say, like 3 gigs or whatever I send out?
So the question is, can we cap the size of the link clone? And the answer is, I believe it'll only grow up to the size that we've allocated to the disk image for the virtual machine that the parent is.
There's a way to back into it too. We can't just say, hey, I just want it, when you get to 3 gigs, do a refresh. But what we can do is you can set it so that when you reach a certain percentage of available space on the LUN, you'll kick off a refresh.
That's a good point. So we can make sure that you never do run out of space on the data store. Question? What's that? Okay, so the question is there a best practice around the amount of time between refreshes? And to me, that's whatever you're comfortable with. Like I said, some people choose to do a refresh every time the user's done using that machine. Now, keep in mind, when we do a refresh, we're destroying that link clone and reprovisioning another link clone in its place.
Not with 4 or 5. With 4 we did.
Well, we're reverting it back to that initial, right? So we're deleting the C drive, but coming back to the state it was when it was originally joined. And we're going to talk about that in some more detail. But I think it's whatever you're comfortable with. If you see that your link clones grow extraordinarily fast, and we're going to talk about this in the troubleshooting section, it may be that you want to refresh more frequently. But that's up to you. Other questions? Oh, yeah.
Can you characterize the kind of data that's written to the link clone in typical environments? And also, so is it transactional? In other words, let's say I am writing a change to the operating system configuration over and over again. It's the same change, but it's being written at discrete moments in time. Is that additive to the size of the link clone? Or is it smart enough to say, oh, this change already exists in the link clone?
Anything that would consume disk space on a physical Windows disk is going to consume disk space in a linked clone. That's the primary reason we have the refresh capability, is to be able to push it back. So anything that Windows does or anything that an application does, it's going to add information out there that may or may not be important information to have. It's just logging and temp files and things like that. It's all going to get written, which will contribute to the linked clone growing.
And to address the first part of your question in a little bit more detail, so I always think of an example of something that will cause a link clone to grow is we have a swap file, not the VM swap file, but the swap file for the XP or Windows 7 VM itself, right? So when I'm sizing out and we're going to talk about this, but another new capability of View 4.5 is I have the ability to create a disposable disk where I keep my swap file for the VM itself and the temp directory. So I don't have to store those things in my link clone, so I can minimize the growth of my link clone. Because something that happens quite frequently that causes a link clone to grow is that swap file. So if I assign a gig of memory to each of my virtual machines, and I have a swap file that's 1.5 times my memory, it's 1.5 gigs, right? And it will thin provision it. It'll get thin provisioned, so it'll grow over time as it's used, but it will definitely grow, right? So I know that if I'm going to have 1.5 gig for my swap file and temp files, I want to have a disposable disk of at least 2 gigs, right? So I have some room there for that swap file to grow. Does that make sense? Does that answer your question? So now we're giving you the ability to break it out. So even if I wait longer to refresh my link clone, I'm not storing all that garbage inside of the link clone. I'm disposing of that in that disposable disk, right?
And are you storing one page file for every VM in the disposable disk?
Each VM has its own disposable disk with its own page file. Yep.
Okay.
Forward.
Sounds like a plan.
The 50 to 64.
We need to talk about that.
Yeah.
Okay. A couple good comments.
Good question. So the 50 to 64, don't take that as like, I saw a couple people taking pictures of the slide, like, oh, they only support 50 to 64 disks. Or machines. It's just a rule of thumb. It's one we've used for a long time. Go back to Jeff's comments about IOs. It really has to do with how you've got that LUN built. VAII, for those of you who don't know that acronym, it's the API for array integration, should help with that in terms of the number of link clones you could have on a single LUN, because it'll help with the SCSI reservation issue. So now instead of locking the whole LUN with VAII, we'll be able to lock the pieces of the LUN. So we should be able to expand the number of VMs that could be hosted on a LUN beyond what it is now, because things that'll generate SCSI reservations or creating a new clone, turning on, turning off a machine, those kinds of things. Yes. Yeah, and NFS too is also a really good solution there, because you don't run into the SCSI reservation issue. That's one of the reasons on my lab there I'm using NFS storage. It's just
one other thing I'd add to that comment, though. When we start talking about 50 to 64, or I've heard 128, when we throw around these numbers, these are just absolute, I'm going to just throw a number out there, right? Until we actually understand what that I/O footprint looks like, we would never say you're going to get 64. We think that's a conservative number, so that's why you've heard that as a rule of thumb. But we need to know that you have enough physical spindles underneath that data store to support the I/O requirements for the virtual desktops, the link clones that reside in that data store. That's the end of the conversation. So that could be 250 link clones. It could be 20. It really depends on the I/O requirements. Does that answer your question? I forgot who asked the question.
Does the remove the 8-host limit for Recomposer?
No, it does not. No. The host
the question was,
does
VAII or VAAI
right.
remove the 8-host limit for the cluster, right? But I believe that next year, and again, this is futures, but next year we should be able to remove that limit with what we're doing with VMFS. So that limitation should go away next year, right? We're all under NDA in here, right? As far as I know.
Golly.
As far as I care.
Let's go to the next slide.
And the other thing here, make the data store size roughly the same sizes, because we have seen an issue where if I'm just going to spool up a pool of 20 machines and I have one large data store and one small data store, it'll just put all 20 on the large ones if it'll fit. It won't load balance across them. But if they're all about the same size, it'll create a replica in each and load balance nicely. Okay, so the link clone itself, we're going to look at the replica. So this replica, like I said, this is that parent VM plus the snapshot, resulting in a new VM. So this replica that we're looking at here in the data store browser started out as a 20 gig virtual machine. So you can see it's 8.5 gig here. So we are thin provisioning these replicas. So we're not going to consume 20 gig of disk space if there's free space inside of that, right? So the next part is the link clone. And when we start looking at the link clone, I'm going to point out this file here, W7test1, this 75 meg file. It's extraordinarily small as it begins, and it'll grow and it'll get larger, right? A couple other files I'd like to point out that we're going to talk about in some detail is this internal disk, this internal disk. And what we store in this internal disk is basically the password information for authentication with Active Directory. Not user password, but computer AD password, right? So the reason that we're doing this is because periodically Windows will change the AD password for that computer account, right? And if we revert back and do a desktop refresh, we can lose that change, and then we'll be out of sync on that password. So now what we'll do is when we actually do a desktop refresh, we revert back, and then we'll look in the registry to see the password that we have. And if there's a newer password in this internal disk, we'll pull it out and write that one to the registry so that it always matches the AD side, right? So this internal disk really helps with us getting back to where we need to be. Another one here, this snapshot. This is also new with View 4.5, with Composer 4.5. The snapshot, what we're actually doing here is once we've created the link clone and we've joined it to Active Directory and we've gone through customization, and we're going to talk more about customization in a minute here, both with Quick Prep and SysPrep. But once it's been joined to AD, then we power off the link clone and we take a snapshot. Now, the reason that we do this is that if we do a desktop refresh, we can just go and get back to this snapshot point very, very quickly. So before, we used to have to completely provision and customize that VM from scratch and join it to AD. Now with 4.5, we can instantly get back to that already joined to AD and customized state, so we can get that link clone back up and running much more quickly with Composer 4.5 than we could before.
Well, one of the use cases this really helps support is like a classroom situation. You know, I've got 30 students using a machine, and you know, who knows what the heck they did during the course of the class. So at the end of the class, I want them to log off. I want to refresh the machine back to the way it was, and 10 minutes later, I want to be ready to rock for the next class. This rapid refresh will help that use case really well. Plus the fact that if you set to, because one of the options you can set in View Manager is I can refresh on log off. So I might log off and then, oh, darn it, I forgot something. And I want to log back on. Well, now I'm in a waiting pattern to get back to my machine.
Two more files we're going to talk about real briefly. The one that's highlighted here is the user data disk, right? Again, it starts out very small, and it would grow over time, and that's where our profile information would be. This user hasn't logged in yet. That's why this is so extraordinarily small. And then the file on the very bottom, this is that disposable disk that I talked about. And again, it's very small, but that's where we would store the temp directory and the page file. And all of that happens dynamically. If we choose to use this disposable disk, you can go in and look in My Computer Properties Advanced, and you'll actually see that we've changed the location of the temp directory and the page file to point at this other drive, right? It's another drive letter at that point. Questions on any of this?
Curious, what's the impact to the OS of decoupling the page file from the OS when you recompose?
So
Validate the page file?
no, we don't want the page file anyway. We're starting from scratch, but decoupling the page file is no big deal, right? Microsoft recommends you generally store the page file on a different disk anyway, right?
Right, but it's always been associated with the operating system. So essentially, you're changing the operating system out from under the page file. So I'm just curious.
But when we refresh, keep in mind, not only does the page file go away, the C drive goes away, and we're just starting over, right?
Okay, so a refresh also kills the page file.
Correct.
Yes.
Yep.
What's the SDD folder? What do you? This is Jim's data store.
Yeah, I remember there's one small file that's in there, and I can't remember what the heck it was. Hey, Matt, do you know what it is? Are you still in here? Okay, maybe he left.
Matt.
Okay, I remember looking in there, and it just wasn't really all that important, so I didn't do anything with it. So I don't remember what's in it. Okay.
Matt Lesak, everyone, one of our desktop specialists. Question?
In previous versions, if you had used data disk and that were all folder redirection, that been fixed now, so you can use...
You can definitely use user data disk and folder redirection. And I know in View 4 we could do that too. I haven't seen issues with that, but
On Windows 7?
So I have customers that definitely do redirection of my documents and still use user data disk.
With XP, it works fine on 4. Remember, Windows 7 was experimental support under View 4, so you may have had some issues with that.
Questions, or can we move on? Okay, this is just a quick exercise. I'm going to try and go quickly. We're behind a little bit. And we're just basically trying to demonstrate the storage savings by using Composer compared to full clones. So the idea here is before we had Composer, if I had a 10 gig template and I wanted 500 machines, I would make 500 copies of that 10 gig template and consume 5 terabyte of storage, right? So the footprint there was 5 terabyte. Now with View Composer, if we have that same 10 gig image and we create a replica of that 10 gig image in all 10 of our data stores, and this is, again, conservative, assuming that we're only putting 50 link clones in a data store, we're going to consume 100 gig for our replicas. If the link clones grow to 1 gig in size and we have 500 of them, that's 500 gig. User data disk, another 500 gig. And the same size swap files we had on the other example. So basically, instead of over 5 terabyte, it's just over 1 terabyte, right? So the idea here is that we're going to save pretty dramatically. And again, the cost, the number that we used here, again, very conservative. We figured $10 a gig for storage. And I think that's high. Anybody have a problem with that number, $10 a gig? So in any case, the point is there's pretty dramatic storage savings in most environments by using Composer. Okay, Jim.
Yeah. So in View 4, we actually, when we released Composer back in View 3, we came out with Quick Prep. And Quick Prep is a utility to very quickly do a customization to a Windows desktop for linked clones. We didn't support Quick SysPrep with Composer until View 4.5. So now it's an option. You can either use Quick Prep for a pool, you can either use SysPrep for a pool. Just a couple of things. SysPrep's going to take longer. Quick Prep, has quick in the name, so that sort of implies it's faster. It's going to be a lot faster provision for you just in general. The main reason to use SysPrep is if you need a unique SID in each linked clone. Because with Quick Prep, we copy the SID across all the clones. Now, don't panic, because they still show up as different machines in Active Directory. They still have their own unique UID. SIDs are used by some applications, and a couple of things you may run into that is like desktop management applications and antivirus that want a unique SID. So we're giving you the ability to do that with SysPrep now. One caveat on this. It will not survive, that SID will not survive a recompose. It will survive a refresh, no problem because of the way we're doing a refresh, but it won't survive a recompose. We'll run SysPrep again during the recompose process, but you'll get a new unique SID. So it's not a 100% solution to the SysPrep issue, but it's a long way down the road from where we were if you run into that. Just curious, any of you using Composer that have had the SID issue? Okay, one or two. Yeah, and that's pretty typical. It's typically application tied. SIDs are becoming kind of an old school way of doing things. In fact, new SID, which is a utility from Microsoft, they're not even continuing to support that just because it's kind of fallen out of fashion. If you both SysPrep and Quick Prep will use the domain account that you set up at the beginning that I showed you earlier. So if you've got customization specs already and you've got an account in there, set already in there, it's going to ignore that account in favor of the account that we put in View Manager. Something just to keep in mind for troubleshooting. Any questions on any of that?
Question.
So you said it's no longer being supported by Microsoft, but what's Microsoft's support position on the SIDs being safe throughout the environment?
It's not an issue, and at the end of this deck, the guy that actually wrote new SID originally, we've got a link to his blog post explaining why you don't need to have unique SIDs in your each desktop. and he explains in detail why that's not necessary. So, there was a question in the back of the room? No? Okay.
I would just suggest that in addition to the blog, if you read the comments, there's been a lot of discussion posted to the blog about situations where specific products have required a unique SID on the machine, even though from a Microsoft security perspective, it's not used for doing machine-to-machine authentication, which was the initial issue.
So for those of you who didn't hear the comment, it is that even though from a Microsoft perspective, you don't need to have unique SIDs in the machine, there are definitely products out there, as Jim mentioned a couple minutes ago, that look for a unique SID on each machine. And as he also mentioned, hopefully they'll move away from that strategy of managing by using a SID. But that is something to look out for, is that some products still do look for a unique SID on each device or in each virtual machine.
Okay, so just a couple other things. We talked about the persistent disk and how you can use that to maintain user profile information. This is where you set it up. It defaults to 2 gigs. You can raise or lower that depending on your needs. And again, as we showed you in the Datastore browser, we do thin provision that. The other thing I'll point out on here is this is where I can say, yes, I want to use a disposable disk, or no, I don't want to use a disposable disk. And this is just part of the pool creation process. So if I'm using a persistent disk, this is what it looks like to the user. Somebody asked yesterday in the session if we could hide that. We can't, but you certainly could hide it through GPO so that the user doesn't necessarily see it. So it'll just look like another disk, and you can obviously set the drive letter. The default is D. This is just a quick mention for your reference. By sometime mid-September, this presentation should be up on vmworld.com along with the recording of the session. I just want to point that out because you probably want to plan a little dinner party around that to review it with your family and friends. This is a utility that we include as part of View that you can use for some certain operations. We have a link at the end to reference this utility and where you would find the documentation for it. Yes.
No, we appreciate it.
I noticed you have PowerShell commandlets in View 4.5. Is it pretty much parity in terms of what you can do in the PowerShell commandlets for VM admin?
I don't know, because the one thing I can tell you is that the 2 guys on this stage are not PowerShell guys. So I'm not absolutely sure on that.
Comments from Matt on that? No? Okay.
So one of the things that we've done with View 4.5 is we've made that persistent disk a first-class object. So this is the dialog where you can actually go in and manage these. You used to have to use that utility that I just showed you to detach it and reattach it, and you needed UIDs, and now we've got actually an interface in here. So what you're looking at here is a virtual desktop that has a persistent disk assigned to it. I can go ahead and detach that persistent disk. I can store it on the same data store or choose a new data store. Being the clever guy I am, I have a data store called Backups with a folder called Persistent Disks where I can store that. So then I can go in, and once I've detached it, I can go in and see the detached disks and see now I've got this catalog of disks that I've detached. Now, one of the reasons I may want to use this is, let's say I change job roles and I need to have a new base image of virtual machine, but I don't want to have to go in and set up my Hello Kitty wallpaper and all my other customizations all over again. I can get my profile retained. I can detach, I can reattach it to my new machine. Now, don't take that to mean that I can migrate from XP to Windows 7, because it ain't quite that simple. But it does allow me to migrate between machines. You also may want to archive disks, so if somebody leaves a company or whatever, I want to detach that disk and stick it in an archived area. You can do that as well with this.
One thing I'd like to point out is... I don't remember.
Fair enough.
I thought I had something. I really did. I'm not kidding you. It was going to be the best thing you learned at the entire VMworld.
Now, I can reattach that disk to a desktop, and then just have that available to me attached to the desktop. When I go in, what I'm going to see is so it's basically my new desktop, which has a persistent disk assigned to it, plus it has that persistent disk that I attach to it. If I want to take my profile information, I simply copy it out of the old persistent disk, copy it into the new one, and then I can go, and you notice this machine has 2 persistent disks associated with it, a primary and a secondary. I can detach that secondary and be back to where I was. This is probably a process you could script. Again, guys on the stage here, not real big script guys, but you should be able to script this as well.
I know what I was going to say. I was going to say one of the big limitations around persistent disk is while it's a great technology because it allows us to separate out the user's profile from the C drive, right, so that we can delete that C drive without affecting the user's data, right? The big limitation here with this technology is that we specifically can't assign that user data disk, that persistent disk, to a user. It's actually tied directly to the link clone, right? So the problem becomes if I'm entitled to two different pools of desktops and I make a change in my profile on this pool and I log into this pool, that change didn't happen because my profile is in that persistent disk that's tied to the desktop in this original pool, right? So that's why we're giving the ability to detach and move it from one machine to another. But we'll never sync those two, right? We don't have that capability. So this is a great solution to separate out that profile, but it isn't a centralized profile management utility, right? It's tied to a specific VM. We'll keep that information intact across refresh, recompose, rebalance, across all these operations, but it's not going to apply to anything other than that VM. So that's the big caveat I was going to throw out there.
Yes. That's fine. You wouldn't use this, right? This, and again, so we don't go kind of down that path. This is specifically about the functionality with Composer, but there are probably more elegant ways of managing user profile information. AppSense would be one of them. Liquidware has a solution. There are a number of solutions out there to manage profile information user to user. And
from VMware, you will see us come up with something, right? Obviously, a lot of you are aware that we did make an acquisition of a company called RTO that is in to do centralized profiles. And again, since we're all under NDA, remember that, right? We will be doing something. It's just not here today, right?
Yes.
Can you adjust the size of the user data disk? If we should have pointed this out maybe, but when you set up that you want to use a persistent disk, you can set the size limit, and we'll thin provision that user data disk, that persistent disk.
Yeah, so you can't go in and resize it unless you're using some other resizing tool to do that. Talk to us offline because I can probably back you into a way to do that.
Question.
I don't know if you're going to cover this, but we store our user data disk on NetApp, and there's been an alignment issue, like the NPR alignment.
Sure.
Where the data disk is not aligned, there's multiple that's not fixable. Is that something that you address before?
I'm not aware of that.
I don't know. That's something we can talk about offline too. Sorry. They were discussing with NetApp an issue around alignment on the user data disk, and we actually don't know the answer to that.
With the master boot record.
Yeah. I'm gonna keep rolling because we're rapidly running out of time, and I promise you they'll throw us out of here at 4:00. So a couple of troubleshooting things. So a few things we've run into a number of times. All machines have the same name and hang on customization. Most common thing is you forgot to install the agent in the desktop, so yeah, that's one fix for that. Customization will fail. Double check that you've actually added the credentials right in the quick prep, like I showed you at the beginning. Just refer back to that slide. Also, make sure that the admin user you're using really can add and delete machines into the domain. That one will drive you crazy. It did me. Another one that we've talked about a little bit is just the user data disks are growing really large and really fast. Some things that can cause that are some antivirus will just punch a lot of information out into those disks and they'll just jump right up really fast. If you're using roaming profiles, big rolling profiles, that especially if you're not using folder redirection to some network share with all their My Document stuff, will do that. And if you didn't defrag the image, again, use that XP deployment guide, Win7 optimization guide. And the biggest thing that will kill you is DNS issues. So you can chase your tail over those. Whenever I do a deployment, one of the first things I do is from that gold image, make sure I can ping the view manager server, forward, reverse, and long and short name. And then just a couple of other general things. The biggest one on this page is don't use vCenter to manipulate View desktops. Do it through the View Manager. There's a utility here called SVI config. It's also referenced at the end of the slide deck, that if you run into corrupt database objects that are, just orphan kind of objects that you need to get out, there's some things you can do to fix those things with SVI config. I'm going to run through really quick Composer disk operations. Most of you are using Composer, and we've referenced most of these disk operations already. So a refresh, really simple, that linked clone starts to grow over time. It gets big. We do a refresh, and we push it back down to its size. We will detach the user data disk if you're using it and reattach it to the machine. The way we do refresh in 4.5 is much quicker, and it's just that reverting to snapshot. So it's actually simpler than the slide even shows. A recompose is a big operation. This is where I'm going to do an update. Maybe I'm going to go from Service Pack 2 to Service Pack 3. I create my new master image, my new snapshot, and again, I'm going to create a new OS disk. I'm going to detach that D drive, reattach the D drive, and be on my way. Now, this is a more destructive one. So this is where the one that won't survive the SID change, or the SID won't survive the change. You'll get a new SID.
And we'll create a new snapshot. The reason we don't get back to that is because we delete that snapshot when we do the recompose.
And a rebalance, just like this slide looks, is I've got a lot of free space on one LUN and not much on the other. I'll go through and look at that, and then we'll decide what machines to move. The other use for rebalance is to relocate machines. Let's say you're using 3 LUNs right now and you decide I really only need 2 LUNs. I can go in and do a rebalance operation, and I can deselect one of the LUNs that I've got in place, do the rebalance operation, and it'll just migrate everything off of the LUN. If you want to move linked clones, this is the supported way to do it. You can't use storage vMotion to do it. You use the rebalance to do it.
Is it still going to refresh the image?
It will refresh the image. It'll actually recompose the image, so this is more like a destructive one.
Okay, and apologies here in advance because I'm going to speed up a little. We're running quickly out of time. Question?
Previous comment. Why can't you use vMotion?
Why can't we use storage vMotion? Okay, I mentioned earlier that if we have that replica in each data store, the link clones in that data store are tied to that replica. Even if I were able to move the link clone to another data store, it wouldn't be tied to that local replica. Additionally, vCenter doesn't know how to migrate that link clone from one location to another. It's just not supported. That's not to say it never will be, but it sure isn't now. Okay, so installing applications with ThinApp. So new to View 4.5, we can actually entitle ThinApp applications to pools of desktops, right? So there's a lot of advantages to pulling those applications out of the actual base image, out of our parent, so that they're not installed locally, right? And I think everybody gets that because I can have fewer base images. So we would recommend that you go down this road and ThinApp as many applications as you can. Now, we do understand that you're still going to be installing some applications in the parent, right? So if you have applications that are going to be used across a wide swath of your users, maybe you want them installed in the parent. If you have antivirus agents, management agents, they can't be ThinApped. Anything that can't be ThinApped, you're going to have installed locally, right? If the other thing here is if we do have to install applications into the parent image itself, the good news is you're in a lot better shape with linked clones than you are with full clones, because if I'm going to update the application, I can boot up my parent image, update the application, power it down, take a snapshot, and recompose to that new image where I've had the updated application, right? So very, very efficient. And as an added benefit, if there's an issue with the application that I just updated and I need to roll everybody back, I can just recompose back to that initial snapshot, right? So a couple different ways of doing this, right? Jim?
Okay. All right, so we're talking about patch and updates, how to handle those. So we've come up with 3 different methods that you can potentially approach Patch Tuesday or any kind of an update you're going to do. So one of them I call the manual method. You've got your parent VM, you fire it up, power it up, do a snapshot just to make sure everything's where you want it, put your patches in place, test. You power that back down, take the snapshot, because remember the Composer snapshot we always want in a powered down state, Recompose, it's Composer. And then, you're on your way. Yeah, sorry. That's why I'm not in marketing. The other one I call the automatic updates method. I leave the machine on and I know heresy, leave automatic updates running, test. Power it down, take my snapshot, recompose, and power it back up and just let it get its next round of automatic updates. One way of handling Patch Tuesday. The other way to do it was if you're using some kind of third-party agent, let's say Altiris, I have my agent installed on my parent VM. I spent a lot of money on graphics. I let the agent do its normal management process, just like I'm managing any physical device. I'm going to uninstall that agent, bring the machine down, create my snapshot, recompose, and then reinstall my agent and let that parent image continue to get its updates. So just a number of different ways you can deal with updates.
Quick question on patching, really quick. So do you not see customers patching their link clones too?
That is another potential way of handling it. The issue is going to be when you refresh, I'm potentially going to blow the patches away back to the way I distributed it. So you really don't want to do it that way. And I'm going to put a moratorium on questions. We'll handle anything afterwards, but we got 7 minutes left. We got to move. Sorry.
Okay. So antivirus, right? So pre-vSphere 4.1, the way we'd handle antivirus is we could, much like what Jim just talked about, right? I could put that antivirus agent in the parent image and set it up so that it would only pull down updated DAT files, but not the engine, right? And then if there was a new update for the actual engine, I would actually do a recompose in that situation, right? So there's issues with that. The other option here is to just not use antivirus. Is that an option for any of you? Okay, it sounds crazy, but I can't spend a lot of time here. But my point with this don't use antivirus is, does anybody in the room have XP embedded terminals? Can I see a show of hands? So a few of you. Do you guys put antivirus agents in those XP embedded terminals? No, nobody does, right? So there's millions and millions of XP embedded terminals floating around in corporate America. None of them are using antivirus, and somehow that's okay, right? But if I say I'm not going to put antivirus in my virtual desktops, everyone has an absolute fit, right? So the idea here is that we're so flexible in these machines, we can refresh and blow them away so easily. I don't think this is crazy, right?
I'd just like to make 2 comments. We're going to talk about a much better way of handling this here in a minute, and Jeff is the one who said that. If you want to tweet anything, not Jim Yannick. I'm just saying.
Yeah, you might not want to throw out there that the guys from VMware said don't use antivirus. Okay, so moving forward, right? And I mentioned vSphere 4.1. Hopefully, while you're at the show, you've heard about VShield Endpoint, right? So VShield Endpoint is an extension of the VM Safe API that we released with vSphere 4 last year, right? But we've extended that API a lot further so that our antivirus partners can actually remove the agents entirely from the VMs, run a virtual appliance on top of ESX, and protect all the machines from underneath. Much, much better architecture for protecting these machines. This is really, really revolutionary stuff, right, guys? So no more agent in the machine, more secure than running an agent in a machine because I'm protecting it from the bottom. I don't have to wait for the threat to exist in the machine itself before I can detect the threat. I don't have to remove about the agent being removed. So discuss with your security vendor their implementation of this. So I've heard that Trend is going to be first to market. Symantec, McAfee, they're on board. So most antivirus providers out there are moving to this architecture because it's a better architecture. Does anybody out here use Forefront? Can I see hands? A couple of you. Remarkably, Microsoft chose not to support this architecture. So it's incredible, right? But if you're using any of those others I mentioned, you're in good shape. This is what it looks like. We run a virtual appliance on top of vSphere, and it protects everything from the bottom, right? So moving forward, not before the end of the year, you will literally have a little shim built into VM tools that this appliance is going to talk to do that management. So no agent will be necessary at all, right? So this is the Trend solution. They're going to be first to market. I'm not here to plug Trend, but a really nice solution. And if I understand, if you go to their booth, they'll show you this running. Really, really slick. I saw a demo. Very impressive stuff, right?
So just a couple of notes. We're down to the last couple of slides here. So Composer and business continuity. Don't forget you got a Composer database to back up. Just make sure you keep that in mind. It's probably on your vCenter database. You can roll it into what you're doing there. If the database is down, you can still log into machines, but you're not going to be able to do any of these recompose, refresh type operations. And you may want to consider protecting vCenter with vCenter Heartbeat because you can protect Composer as part of that for high availability for vCenter. With DR, just a couple of tips on this. We kind of already talked about replicating the user data, replicating any of the profile information to a remote site. You're going to want to make sure you've got some View Manager servers up and running. Really want to make sure all of your gold image and snapshots are being replicated off-site because that's a lot of work if you've got to recover that in a disaster. You can architect a really good disaster recovery for desktop solutions using Composer, using View and Composer. This is a list of resources, just a couple slides here at the end, and that's what we had. Thank you very much for attending.